Wow, what a great start to this Matsuura live stream. Now coming up throughout the hour, we're going to be looking at the MAM technologies, also the new MX420. But for now, we're going to be talking about a partnership and also some incredible technology. I was going to begin to describe it myself, but I thought I'd let Tom do that as he's the man. Tom, can you introduce yourself, please?
Okay. Hi, I'm Tom Houle. I'm the director of LUMEX North America, and I'm responsible for our additive subtractive line of equipment.
Okay, now what is the LUMEX? Well, let's find out. Can you just explain what this technology is, because it really is awe-inspiring.
You bet. It is a powder bed fusion additive machine with a subtractive machine layered on top of it. So in one platform we sinter and laser melt material together and then actually machine it to finish shape, finish surface dimensions, and fine tolerances.
Okay, so we're going to look at some applications shortly. If you've got any questions about this technology or anything that we're talking about here on the Matsuura stand, then of course put them on whatever social platform you're on and we'll answer those. Yeah, Tom, firstly, let's look at this application and talk us through how the machine has actually delivered this part.
Sure. So this is a sample part. Both of these parts were built on our machine. On the right-hand side, the machining was turned off, and on the left-hand side, the machining was left on. So we do every 20 thousandths of an inch, we machine to final dimensions. So deep pockets, deep holes, outside surfaces, outside corners are all machined within the same platform. So you can transfer these parts either to a finished CNC machine or use them right out of the machine, which is one of the critical features of why we want to bring the LUMEX.
Okay, so who would use this sort of technology then, Tom? Let's talk about where you've put these machines, because I mean this one here is actually not a machine, and the reason being, when you make them, you sell them. So we've obviously got what is a cardboard version here. Is that correct?
That is correct. It's a mock-up. It demonstrates all the capabilities of the machine, but obviously not the real machine. Typical users are mold makers, people who want to implement not only additive but conformal cooling, integrated venting. People who control design of the parts, design of the molds is a really big application for us and where most of our customers are using it. And then also for time to market improvements, they can now build their development molds, unit molds, whatever, book molds, whatever they want to call them in the product development field. They can get those actual molded parts quicker using our technology.
Is it fair to say this is for parts that really can't be made any other way?
Yes, good way to describe it, especially when you have a conformal cooling or integrated venting. It's the only way to do that is additively.
Okay, tell us about the materials as well that can be used and how you may go from one to the other, and some of the challenges, and also some of the highlights and features.
Sure. So most of our materials are non-reactive materials, so tool steels that can be with high chromium content, almost like stainless. We also have two versions of stainless, really for parts and applications that have good weldability, good repair.
Okay, now we're going to have a look at some more of these parts shortly. We're also going to meet a couple of professors. Tom, can you explain the relationship you have with the Purdue University, because we're going to meet those guys in a minute.
Yeah, so this is breaking news. We're proud to announce that we've developed a partnership with Purdue University, one of the greatest engineering schools in the U.S., and they're using our machines, two of them, one for critical materials or reactive materials. Because that market is so intense on material validations, Purdue has taken on the responsibility to bring those types of materials using additive subtractive AM to market. And they've selected our machine to do that. We're very excited to partner with them, and we see great things.
Okay, people should visit you at the show, shouldn't they? Who should be actually visiting this area to talk to you?
Anybody who's interested in AM, but really people who see the future. Our machine allows manufacturing without people involvement, so it's a lights out, true 24/7 manufacturing work cell.
Because there's a lot of additive machines, there's also a lot of subtractive machines, but having one together is a real leap in technology, isn't it?
Yeah, we want to use every part produced out of our machine directly into the final application. No post-processing. No
post-process, great stuff. Great to meet you, Tom. Come and see Tom at IMTS. Now I'm going to meet two gentlemen, two professors. Now firstly, if you could just introduce yourself and tell us about the Purdue University.
Sure, my name is Michael Seeley. I'm an associate professor in mechanical engineering at Purdue. I've been there for about a year now.
And yourself?
I'm AJ Malshi. I'm Distinguished Professor at the School of Mechanical Engineering, and I've been in the manufacturing collectively probably about 40 years. So I'm super excited about this partnership.
Okay, yeah, and in your words, talk us through your involvement in the partnership with Matsuura and the LUMEX technology and what it does for you.
Sure. So I've been involved with Matsuura and the LUMEX system since about 2016. And it's something where it's a very important strategic partnership with my transition to Purdue, because Purdue is committed to investing in what we call convergent manufacturing, which builds upon this application space of combining additive and subtractive manufacturing. And what makes it so unique or so special is the fact that we can do this for any critical material like magnesium or titanium or aluminum. And so it really maximizes our research potential.
Okay, can we just get the camera on some of these parts as well here? Perhaps, talk to us about how this technology would actually create something like this, and the elements of it.
Sure. So the way it works is you start with a powder bed fusion process, and it's very standard AM process. But what's unique about it is the fact that it now can come in and machine typically every 10 layers. And so that's a unique capability that you don't really see in powder bed fusion.
Okay, so you're layering 10 layers and then you're coming in and machining after that, yeah?
Correct. And so that enables you to have machine surface finishes anywhere throughout the build volume.
Okay, now does that differ with the different materials that you're layering?
So typically no. I mean, you can do a standard machining process, but the ability to do this on aluminum versus one type of steel versus another type of steel may change your machining strategy some. But for the most part, the fact that you can do it anywhere on internal features or external features really gives you the competitive advantage.
Okay, and how would you best describe what the LUMEX does that other machines can't?
So LUMEX machine really brings a very unique capability to manufacture critical materials. And when I meant critical materials, that as you would find out in manufacturing, we are more and more using high performance material, titaniums, magnesiums, berylliums, aluminum, and these are all critical materials in short supply, so we need to use those resources very carefully. And LUMEX machine allows critical materials and non-critical materials to add, subtract, and phase transform. So if I may just add that what Dr. Seeley said, we're looking at convergent manufacturing, and what is it? Basically, we are trying to combine multi-materials, multi-processes, along with smart digital manufacturing. Now what that does is that typically you would hear word common design for manufacturing. We are really going to now manufacturing for design. That means we would have so unlimited space that we can achieve functionalities, resilience, and sustainability all in one design. And that is convergence.
Exciting, very exciting. Perhaps you could just tell us maybe a project to finalize here that you have done on the actual machine that you don't think you could have done without the LUMEX.
Sure. So one of the projects is geared towards a biodegradable medical device made out of magnesium. And so one of the unique capabilities is the fact that we can do machining on something like a biodegradable magnesium implant for things like fracture fixation. And so this is the only machine in the entire world capable of being able to print using powder bed fusion with machining to achieve a biodegradable implant where you can really control how fast or slow that device degrades for any patient.
Wow, what technology. I'm going to be going over to Tony very soon. And before we do, we've just got one gentleman I think that would like to come and just jump in on the stream.
I wanted to actually, Tim, come on in. So I want to introduce to Tim, but before that I want to say that Purdue has a long tradition in manufacturing, as long probably as LUMEX. So companies with the longest tradition in machining and manufacturing, we call ourselves boiler makers. And I would like to introduce to a fellow boiler maker.
So a fellow boiler maker. Tim, introduce yourself.
Hi guys, I'm Tim Schirnbaum, I'm the Chief Technology Officer here at AMT, host and producer of the IMTS for 2022.
Good stuff. It's been a good show so far. It's only been on a few hours, but the floors are busy.
Yeah, very busy, busier than we expected on a rainy Mondays. That's always good news. And I would like to extend my congratulations and appreciation for Matsuura and the announcements that's happening here, not only as an exhibitor, but also for our industry at large.
Okay, brilliant. Thank you very much. More comments and questions, get them in. We've got a comment. Nice. Alan Scrooby, Chief Technical Director at Ragnar Rock Technologies on LinkedIn. Good to see you're watching. Gentlemen, thank you very much for your time. Coming up in the stream, we're also going to be looking at the MX420 and other technologies. But in the meantime, I'm going to pass you over to Tony, who's at the MAM with Leo.